Purkinje fibers, all of these are nodes. Okay? You have your first one up here, your sinoatrial node is the pacemaker of the heart. The sinoatrial node is a pacemaker which regulates atrial conduction or contraction. Okay, so again, the sinoatrial node regulates atrial contraction and sends the signal from there to the AV node, which is called the atrioventricular node. Okay, again, the sinoatrial node is a pacemaker that regulates atrial contraction. It sends a signal from the sinoatrial to the atrioventricular node, which is here. Okay? So, sinoatrial to the atrioventricular node. Okay? The AV node then receives the SA signals. That means receives sinoatrial signals. So it receives SA signals to contract the ventricles. This entire structure, this entire process is to contract the ventricles. Okay? So again, the atrioventricular node receives SA signals to contract the ventricles. Okay? Now the atrioventricular sends it to the atrioventricular bundle of His. Okay, not sure why that. Oh, His. It's not like his or hers. It's his actual name. Okay, the guy that created it. So the AV bundle of His. Okay, the bundle of His carries electrical impulses from the AV node to the bundle branches for ventricular contraction. It's a long one, but again, carries electrical impulse from AV node to the branches, which here are the branches, your bundle branches, for ventricular contraction. So again, this whole process is to contract the ventricles. So the bundle of His receives it from the AV node, sends it to the branches to contract for ventricular contraction. Okay? We're ready to move on, or is it going too fast? Or you're all good? Okay, good. So now you have these bundle branches. You have right and left bundle branches. The right and left bundle branches carries electrical impulse from bundle of His to Purkinje fibers. Again, for ventricular contraction.
I have a lot of drawing still to do.
Again, carries electrical impulse from bundle of His to Purkinje fibers for ventricular contraction. It's his name. The guy that found it, that did the whole conduction, it's his name. He's German. I looked up a long time ago because I was curious. Because all the girls are always like, what's bundle of Paris? I just want bundle of Paris. It's not a sexist thing, it's just that was the guy that created it. Okay, I found it. Now, the Purkinje fibers, these right here, your Purkinje fibers carries electrical impulse from right and left bundle branches to the right and left ventricles for contraction. That's the final step. Okay? So, what is this one on top? Sinoatrial node. Sends an impulse to the AV node for contraction. AV node receives it from SA, sends it to the bundle of His. Bundle of His receives it from the AV, sends it to the bundle branches. Bundle branches receives it from His, sends it to the
Purkinje fibers.
Purkinje fibers finally contract the ventricles. So this is why, since you don't have this heart at home, I mean, of course you can take pictures of it, but you'll have to take all like inside, outside. If you draw it, you have the same exact step. You have the sinoatrial, the pacemaker of the heart, that sends the signals to contract the ventricles. So this is the main part of it. So it sends the signals to the AV node. AV node sends it to the His to the branches to the fibers. And it contracts. So if you can draw this picture to understand it, you're fine. Okay, so try to go through. What does the sinoatrial node, without looking at notes, what does the SA node do?
sends electrical impulses to the
Atrioventricular
Yeah, so
node.
it's a pacemaker of the heart that starts the impulses, sends the impulses to the AV node for ventricular contraction. The AV node does what?
Sends the nerve.
Receives it from the SA, sends it to the
Bundle of his.
bundle of His for ventricular contraction. What does the His do? Receives it from,
Atrioventricular.
sends it to the branches for ventricular contraction, then just go down to the pinch. Okay, I think you understand the steps, right? So does that make sense? Any questions with that? Does the drawing help you, or is it easier to look at the model?
I think this is easier.
Yeah, so any way you want to do it. I know that some people like to make flashcards, or some people like to have study guides. They're your study guide for the conduction. Don't worry about taking pictures of the heart, because you should basically have the same idea. Same thing. Here's your atrium, here's your ventricles, the same exact picture. It's just a weird way to draw the heart, which I just learned how they created that heart. Yeah, it's disturbing. Do you all know how they got that heart shape of the heart? Like, of course, Valentine's Day, you know Valentine's Day is like a massacre. But do you know how they got the shape of the heart?
No.
like together.
I wish it was that pretty. No, it was a pervert that's found the breasts of women, and so or the back of the women when they're down. Yeah. Yeah, to show the butt, the female form. That's how they got it.
Oh.
So one guy had it, said it was a breast, but the other guy said it was a shape. Yeah, so I was like, oh, that's great. I'm like, assholes. But yeah, so, yeah, sorry, this too. Okay, do we have anything else? Okay, so what is a pacemaker? What is a pacemaker for?
Monitors the heart.
Yeah, cool. So it monitors. It helps. So it maintains an adequate heart rate. So it's maintaining adequate heart rate. It's monitoring the heart to make sure that it's beating properly. Okay, if you've ever heard of AFib or all the different things that can happen in the heart, how it basically spaz out. Okay, or one side won't be conducting as hard as the other side. That's the pacemaker. That's why people have to put an artificial one, because their SA node is failing. Okay? Why does the heart need two of them?
For like left side.
Yeah, there's left and right side. No.
Wait, say that one more time?
You said why they need two of them?
Yeah.
For left and right side?
Think a little more detailed. Or does anyone have, or what is the question? Is that question still in there? Need two of them? Okay, so what we found, I'm trying to figure out how I can explain this, because you'll understand it later, but basically why the heart needs two of them, there'd be no blood flowing in either atrium or ventricle, therefore the heart would be pumped working too hard if it just had one. And if it just had one, it would have to take care of all of that. So just like you're saying, it has to take care of right and left. Yeah, that's the essential, like with us, how we understand what you're saying. But for people that have no clue, it's basically that there would be no blood on that other side. So the heart would really have to pump and work extra hard. Yeah. Okay. All right. So you ready to go through the heart vessels? I think, is that the last part of it?
Yeah.
Okay. You still wanting to go through appendix 21 and 22? Okay, good. All right. Let's see. All right. So, y'all ready? Yeah. Okay. So what is this one? Good. The superior vena cava. Good. Or however it's spelled. What does it do? What does SVC do for us?
Takes the oxygenated blood and takes it into the right atrium.
Yeah. So it drains DO2 blood from head, neck, upper limbs to the atrium. Okay. Good. SVC drains DO2 blood from head, neck, upper limbs to right atrium. Okay. Now you look below the heart. You flip it underneath, and you look at the bottom of it. What is this one? Inferior vena cava. What does it do? Drains DO2 blood from organs of what? What cavity? Okay, yeah, abdominal, thoracic region, and lower limbs to the right atrium. Okay, so superior vena cava, head, neck, upper limbs. Inferior vena cava, all the lower organs of the abdominal, thoracic, and the lower extremities to the right atrium. Okay. Now,
To the right atrium?
yes,
Both of them?
yes. Now you see all these vessels right here, these cardiac veins. Okay, you have cardiac veins. The arteries are called coronary arteries. So the cardiac veins, what did they do?
Returns deoxygenated blood.
Okay, CO2 blood from the myocardium to where? What's this big highway? A coronary sinus. Okay, so you can either say drains CO2 blood from the myocardium to the right atrium, or you can just go drains CO2 blood from the myocardium to the coronary sinus, because that's the next step. Because you can't get to the atrium before you get to the coronary sinus, right? Okay. Okay. Let's see, cardiac vein. Now, the coronary sinus. What does the coronary sinus do? Receive CO2 blood from the what? Cardiac veins to where? Right atrium. Good. Okay. Everyone understand that? Am I going too fast? Too slow? Are you still with me? So good? Good. Okay. Let's see. Now the pulmonary trunk. Here's the pulmonary trunk, right? On this side. So if you look at the heart, this is always confusing. So later when you get comfortable with it, when we go to the cadaver, I'll tell you how to tell the difference between the SVC, the aorta, and the pulmonary trunk. It's a real easy way, okay? But for now, let's just not worry about it. So you have this trunk, this big tree trunk. The pulmonary trunk does what? It receives CO2 blood from the
semilunar? Or?
So from the right ventricle goes through that, the pulmonary semilunar. So the pulmonary trunk receives CO2 blood from the right ventricle to the what?
Right,
Right
and
and
left
left.
pulmonary veins.
Arteries, because it's going away from the heart. Okay? So that's the biggest mistake people make is they look at the color and they assume it's going to be that one, or they know it's CO2 blood, so it has to be a vein. Okay, so remember, if it's going away, it's an artery. If it's going towards, it's a vein. Okay, so good. The pulmonary trunk receives it from the right atrium, sends it to the right and left pulmonary arteries. Okay, good. Now the right and left pulmonary arteries, they receive CO2 blood from the pulmonary trunk to the right and left lungs. Okay, you won't have to know until later on how it goes. Arteries, arterioles, capillaries. Okay, arterioles are just little arteries. That's basically what it is. Okay. Okay, so pulmonary arteries receive it from the pulmonary trunk to the lungs. Now the pulmonary veins sends what type of blood? The veins, pulmonary veins. Good. Pulmonary veins sends oxygenated blood from the lungs to the left atrium. Okay, so let's just go through it real quick. We have the right atrium. It receives it from 3 veins. What are those 3 veins?
Superior.
And coronary sinus. Good. Now dumps it through, sends it all through. We already did all this stuff. Now shoots up to the pulmonary trunk. What does the pulmonary trunk do? Receives it from the
Right
right ventricle, sends it to the right and left
Pulmonary
pulmonary
arteries.
arteries. The
Away.
coronary arteries go to arterioles, capillaries, and the lungs. The lungs oxygenate the blood, clean up all the crap, and then they send it back to the heart by way of what? Pulmonary veins going towards. The pulmonary veins then get it from the lungs and send it to the what?
Aorta.
The left atrium. Good, good. Now, left atrium goes through to the left ventricle shoots up to the aorta. So now on the aorta, we have certain parts of it. The one that's going up is called the ascending aorta. It arches, aortic arch, it drops. Descending aorta, or you can call them thoracic, abdominal aorta, you can call them those. Or you can just say the basic descending aorta. Okay? Now, when it goes to the aorta, do you see these 2 little dots, these little knobs right here? What do you think these are for? Anyone know?
like too much at once.
That's a good guess. I see how you're getting there. Kind of like a little like blow off valve, like turbo. So yeah, basically, if I put the heart in the back, what these do is before it goes to the aortic arch to go to the body, the upper, the lower, the coronary arteries have to get the blood, right? It has to get oxygen to the heart. So these are where the coronary arteries get the oxygenated blood, send it to the myocardium. Myocardium uses it up, then the cardiac veins take it. Okay? So we have the coronary arteries that function, you can say, carries O2 blood from ascending aorta to myocardium. Again, right and left coronary arteries carries O2 blood from ascending aorta to myocardium. Okay. Now we're going up the ascending aorta. What do you think the function could be for the ascending aorta? Sends O2 blood from left ventricle to where?
The aortic arch.
Aortic arch. Good. So the ascending aorta takes from the left ventricle, sends it to the aortic arch. Now the aortic arch sends O2 blood from the ascending aorta to the descending aorta. Now, there are 3 branches that it has as well. I don't think you need to know these yet, so I'm not going to freak you out with them. And these, they seem hard right now because they have a lot of weird names, but once you hear it and I can explain it to you, I can teach you tricks that makes it simple. This should be a fairly breezy test for you if you understand it and you're honest with either Bree or myself. Okay? So for now, let's just go ascending aorta, sends it to the aortic arch. Aortic arch takes it from ascending, sends it to the descending. But we do know there are 3 vessels that are on top of the aortic arch that has to go up and down, right? Okay? Now the descending aorta, what does that do?
Takes O2 blood from the aortic arch
To the lower body. Yeah, exactly. So the very last thing on here is what's known as the ligamentum arteriosum. Okay? This used to be called the ductus arteriosus. What this is when we're still in our mother, have you had a bowel course kind of about pregnancy, about childbirth, a little bit about how the mother is responsible for breathing for the child and for oxygenating the blood for the child. Okay, so the child essentially, if they had oxygen going through, our DO2 going through here, it would go to the lungs, which could drown the baby. Also, if it's too much oxygen, it could be bad for the baby. So this used to be a little valve or chamber or channel that would dump all the blood through, so it would never leave. So when you're born and you make your first breath and you're screaming and crying, after a while what this will do is it will shrivel up, it will shrink, and it will turn into a ligament. The ligament then, in a sense, holds these 2 together. So the ligamentum arteriosum connects the ascending aorta to the pulmonary trunk.
Could you repeat?
Or aortic arch, but anyway, yeah. Ligamentum arteriosum connects ascending aorta to pulmonary trunk. Now, the typical heart border, just cross out. If you're a Dr. Smith student, cross out, which all of you are, so don't worry about